Hello everyone, let's look at Leetcode question 48, rotate image. In this question we're given an n by n two-dimensional matrix representing an image, and we have to rotate that image by 90 degrees, clockwise. To do this rotation it must be in place, so we cannot create another two-dimensional matrix and modify it this way. Here are the examples, but before we look at them, let's look at the constraints. So the n is equal to the matrix length, which is m of I dot length, so the rows and columns are these sizes, and n will be between the dimensions 1 to 20, and the values of the cells will be between negative 1000 and 1000. So let's look at the examples. So here we have the first example, matrix 1 2 3 4 5 6 7 8 9. To understand it, we could basically think of the center of the matrix as a circle center, and the outer edges are moving around in 90 degrees. So 1 and 3 are exactly 90 degrees apart, and if we would move 1 to 3, that would be a movement of 90. Same applies for the edges. The middle point 2 to 6, 6 to 8, 8 to 4, and so on. So the output would be the following, and this is the correct solution. And now how exactly would we solve this? So to solve this, in a concise solution is first to reverse the matrix and then flip the values. So we have reversed the matrix in this example. So 1 2 3 4 5 6 7 8 9 becomes the following. Notice that we don't flip the values within the innermost array, but just the outer array values. After we have reversed the matrix, we can now flip the individual cells by the following pseudocode here, describing for I in range the size of matrix, and for j in range I plus 1 size of matrix. We flip those values. What does this mean? Well, essentially, since we have reversed the matrix, the cells apart are approximately 180 degrees rotated. So now we have to compensate by flipping negative 90 degrees to make up for the 90 that we have over rotated, making it just the same as rotating 90 degrees. So in this first example, let's start at cell 0, I plus 1, 0 plus 1, 8. So 0, 1 becomes 1, 0, 4, 8. Next, 0, 2 becomes 2, 0, 1, 9 are flipped. We go to the next row, so 1 plus 1 is 2, 1, 2 becomes 2, 1, so 2 and 6 are flipped. And this is the final result of the first example. This is the solution. Let's look at the next one. So it's going to get a little more tricky here. Same concepts though. We start at the initial cell after reversing it. So here we have the initialized reversed matrix. Next, we want to rotate. So the first cell is 0, 1, 1, 0, they're flipped. 0, 2, 2, 0 flipped. 0, 3, 3, 0 flipped. And so on. Next row is 1. So 1 plus 1 is 2. We go to cell 1, 2. Therefore, 1, 2, and 2, 1 are flipped. 4, 6. 1, 3, and 3, 1 are flipped. 1 and 7. Next row, 2 plus 1 is 3. So 2, 3 is 9. Therefore, 3, 2, 10, 9, and 10 are flipped. And this is the final result. Let's look at the code. Here's the code. As we said, we first want to reverse the matrix. Then we simply loop through the rows and then the columns. I, j. I in ranged length of matrix, so excluding the final value. And for j in range I plus 1 length of matrix, we flip the values. So here we define matrix at ij and matrix at ji, and redefine it as ji, ij. Submit. Very nice. So this solution works. Now finally for the time complexity. So in this code, we have two nested loops. The outer loop iterates the length of the matrix times, and the inner loop rotates length of matrix minus 1 time. Therefore, the total number of iterations is approximately n to the power of n minus 1 over 2, so n squared basically. So the time complexity is O of n squared. And the space complexity is O of 1. Thank you so much for watching.